Gandhi and vital mission of OPG's University, Rajasthan, India, to present advanced EEP protocol sensors, multi-parameters of quality of service with congestion control for real-time mobile network networks.
Okay, good afternoon all. So my topic of research is advanced protocol, considering multi-parameters for the QoS with the congestion control for the real-time mobile ad hoc networks. So this is the effort to use the uh, mobile networks or mobile networks managed for the real-time application because nowadays due to the radiation of the mobile
Mr.
phone,
Nithin, Mr.
especially
Nithin,
from the mobile phone towers.
Mr. Nithin, you are speaking with the head of two equipments. Please switch off air.
Sir, I think it is due to other mic. Okay, so this is the my research is targeted to reduce the radiation that everyone is facing nowadays because of the mobile towers. Because nowadays we are having the mobile towers erected all over the city, and the radiation is increasing. But the reason is that we are using the system of cell phone. That is, we need to have the geographical area divided into different cells, and they have to be have the towers. But if we use the mobile phone themselves, which are in everyone's pocket, to communicate the signal, relay the signal from one place to other place, then definitely it will reduce the radiation, at least from the mobile phone towers, because there are so many cases of cancer being detected for the people who are living around the mobile phone towers, and there are so many cases filed in the court. Now, abstract of my work is my paper is dynamic node topology and finite memory capacity is the main issue which is not allowing these manets or the networks based on without any central tower to be utilized because of they are very difficult to implement, especially because nowadays the data need of the data transmission is increasing tremendously, and my research is to make these manets or the mobile networks as efficient as possible so that they are able to transmit the data in the real time. That is my topic. So there are so many causes for this because of the congestion is one of the cause. As you know that there is a busy working day or busy working time, rush hour, and there are some squares get choked with the traffic. So same thing happens in case of the mobile phone, and they literally cause the packet loss, long delays, and packet efficiency of the whole network is reduced. So I am developing a protocol which is called as Enhanced Congestion Control Routing Protocol, which I call it as a QAODV, and which is based on the main mobile network protocol, that is AODV. The performance of this QODV is found better than existing cluster gateway switching routing protocol, because actually AODV is for mobile communication, and I am trying to use the other protocol, that is DSDV, and I'm trying to combine two protocols so that I get the better efficiency. That is the case. Actually, the CGSR is a protocol which is used for controlling and controlling the wireless sensor networks where there is a fixed infrastructure and there is central node which is controlling all these things. But I'm using that in the manets mobile ad hoc networks. So there are so many problems that are here that I'm trying to address, and my proposed method is targeting, and it is based on selection of the temporary cluster heads. Means as you know that these mobile networks that I'm working on are means ad hoc in nature. Means there are so many nodes, just like our mobile phones are. If you consider a railway station or any crowded place where the people are moving here and there, so these are just like nodes and they are moving, and there is no any basic infrastructure, and there is no any means someone who is going to control the thing. But my protocol will select one of these nodes or one of these mobile phone as a cluster head, temporary cluster head, and that cluster head will transmit the signal to other. Means in that way, this protocol will the and their heads, and the data will transmitted from one place to other place. So as I told that this is derived from the AOD protocol, and it incorporates cluster head selection methodology from CGSR protocol. So I'm going to select the cluster head from the gathering node of the magnets. Selection of the cluster head is based on the energy level of the mobile node, means which mobile node is having more energy is considered to be a cluster head, because that node has to transmit the signal from one node to other node, one node to one cluster head to other cluster head, just like in cell phone towers.
Mr. Nithin,
Yeah.
please conclude your presentation. Sorry to say that
Okay, okay.
communication, your communication is not effective. Please
Yeah.
conclude.
Okay, so cluster to cluster data transmission that I'm telling, that here you can see that there are clusters and and this is the cluster head selection algorithm. Based on that, we'll select the cluster for this particular operation. Okay, then there are number of parameters that are chosen for a simulation, because it is not possible to actually build the network in hardware in the laboratory, because it is difficult at this moment, and there are so many simulators available for that. So I'm using the simulation software MS3 and using certain configuration for that, that is here. And then methodology, I'm going to apply different parameters and trying to find out the result. And ultimately, I got the result that average end-to-end delay for my QODV protocol was less. Means we need the delay to be less, and that we have achieved. Secondly, we want to reduce the routing overhead. You can see that in the QODV, the routing overhead has reduced, and the packet delivery ratio has increased, and throughput has also increased for this protocol. In this way, I found this QOD protocol effective for this communication. Thank you.
Thank you, Mr. Nithin, for confining your presentation